Page number 15. This is shortest path problems. This is sixth topic in our unit, and the graph is given, and for each edge, so the weights also given. For example, A to D, there is a weight 2. That means to travel from A to D, so the distance is 2. Like that we have to assume these are called as weights. An example clearly given. So example given clearly. Solution. So how many paths are there between A and Z, and what is the shortest between A and Z? That is using Dijkstra's algorithm we can find out. Now see how we will proceed for this algorithm. And now this is the 16th page, planar graph. This is 7th topic in our unit. Now what is planar graph is given. Definition. Now here example is given is K4 planar. Now the graph K4 is planar. So why? Because in the first diagram we are drawing the edges with the crossover. Okay, now the same diagram we can write like this in the second diagram without crossing the edges. So that's why this is called as a planar. So that is the main definition of the planar graph. Now in 2, example 2 is also given, whether the cube we can write like this without crossing any edges. Now example 3 also given, so whether K3 comma 3 is planar. Now observe in the first diagram V1 V2 V3 V4 V5 V6, that is a K3 comma 3 graph. Can we write this graph again without crossing any edges? Now observe here the graph is given, so without crossing edges V3 to V4 there is no edge. Observe, if we draw V3 to V4, then compulsory it crosses with any edge. So that's why we cannot draw K3 comma 3 without crossing edge. So that's why K3 comma 3 is not a planar graph. That is given. So topic in planar graphs, this is also very important. And Euler's formula is given here. Observe that. So this is also very important, Euler formula. And some examples also given. Based on that one, you can calculate the regions. Region means boundaries. Boundaries you have to calculate. Now next last page 17th, graph coloring. That means we have to color a graph. Graph coloring is nothing but we have to give the colors to the vertices. Now definition of a chromatic number is also given. That means minimum number of colors which we can give for a graph. We can color the vertices. Now find the chromatic number of a graph given the example here. So in graph coloring there is some rules are there. If two adjacent vertices are there, we cannot give same color to those vertices. Observe mainly. In a triangle, observe we have to give three different colors because any two vertices are adjacent in a triangle shape. So example clearly shows here what is the minimum number of colors we can give. So like this we have to give. Then what is the minimum number of colors given, that is called as a chromatic number for that graph. So clearly we mentioned here. So up to this one, so we have completed the notes for part 1 in graph theory. So very important all these things are. So clearly note down your answers, I mean your uh, notes in white papers or in your notes. Thank you.